Hi there! Some time ago I bought a Raspberry Pi version 4B to experiment with it. The power of the device and the amount of memory available made me think that I could actually use such device as a regular desktop computer for lab usage. Just to run quick searches on the internet or write a few lines of code for an Arduino and download them on the board and things like that. Now, while for the most part I found this sort of computer useful, sometimes it was frustrating to wait for read-write operations to and from the microSD card. And then I learned recently that the Raspberry Pi 4B comes with the capability to run out of a real hard disk drive connected to one of its USB V.3 ports. And since USB V.3 ports are fast, I thought that using a Raspberry Pi that way should help a lot with performance, and so I decided to give it a try and see if I could make my lab PC work better. Here is what happened. Here is the RPi I currently use as a lab computer. It is connected to a power supply that has a button to turn it on and off, and to an old monitor that I connected through an adapter. Let's turn it on now to make sure it still works, since last time I used it was about 1 month ago. Here is the usual initial rainbow screen, and from there it shows for a moment the RPi logo, and then the display blanks out for a few seconds until it finishes the boot procedure. Now I can input my password, and finally after some more time the desktop appears. What I would like to do is to change this setup to try to speed the system up so it will become more fun to use. And that basically consists in removing the microSD card from here and use instead a hard disk. And for that I bought on Amazon this nice Samsung 500GB external solid-state disk for a very reasonable price. Since it connects to a USB V.3 cable, it seems perfect for this job. If you need an SSD like this or a different one, you could use my affiliate link in the description below to buy one, and so you will indirectly support the channel at no extra cost to you. Now, since I have two devices, the RPi and the SSD, that needs to stay connected and work together, I decided to build a nice box to save some desk space. The RPi will sit here on the inside, and the SSD will stay on one side of it, also inside the box. The box has openings to access all the connectors on the RPi, and also has another opening for the SSD connector. The cable from the SSD to the RPi will be routed on the outside of the box, since it is very small and it should not create much clutter. And since we talked about the case, here is the code I wrote on OpenSCAD to make it. There are two parts, one is for the actual box and one for its cover. They are both made out of a simple cube, but I made a few slits on the bottom of the box and on the cover to help with the airflow, so the components inside will not overheat, especially the RPi. As usual, I'll make this code available to you through the eleneasy.com website. The link is in the description below. According to the Raspberry Pi official website, the best way to prepare a microSD card or a disk to boot with the Raspberry Pi OS is to use the RPi Imager. The RPi Imager is available for Windows, for Mac and for Linux. Just head to the Raspberry Pi website and download it from there. However, if you are a Linux user, there is an easier way to do that, and that's because the RPi Imager is usually available in the repositories of all the major Linux distributions. Since my workstation runs Fedora, installing the RPi Imager is as simple as firing up a terminal window, log in as root, and run the command dnf install rpi-imager. After confirming with a yes that I would like to install the tool, the package manager takes care of the rest. The same command can be used for any other Fedora-based distribution. Substitute instead dnf with yum for the Red Hat distributions, and apt for the Debian-based distributions. It's that easy. Once the package has finished the installation, we can easily find the tool right in the accessories under the name of Imager, with a nice Raspberry icon close to it. Once the tool is installed, we just run it and we are presented with a very simple interface that requires from us just 2 pieces of data. Before running the program, however, make sure you have connected to the computer the disk you want to image. Once that is done, just click on the Choose Storage button to get a list of all the devices we can use for the job, in my case the Samsung SSD. Then you can choose the OS by clicking on the Choose OS button. And actually, when you click on this button, you are presented with a number of options, not just for the Raspberry OS, but for a number of others. All the work that has been done for several teams all over the world for the Raspberry Pi is condensed here, just at your fingertips. In my case, since I wanted a clean Raspberry Pi OS installation, I used the recommended option at the very beginning, and then I clicked on the right button. The imager at this point will ask you if you are prepared to lose all the pre-existing data on the disk, and once you accept, it starts downloading the OS, then installs it on the disk, and finally it verifies that the image on disk was transferred correctly. And that's all. Much easier than old times when the first Raspberry Pis came out. Isn't that great? Once I got the imaged disk, I decided to connect everything together on the fly and make sure that the fresh installation was fine. I therefore removed the old microSD card from the RPi, I connected the disk and the monitor, and then I fired it up. First thing I noticed was the OS running a one-time routine to resize the disk partition to be able to use all of it. Then the system came up and presented me with a dialog to run the final setup. So I set the things like a country, the time zone and the language, and then I had to change the default password for the user Pi. Another question was there to check that the monitor was used correctly. And then came the setup of the Wi-Fi network and password, after which I waited a little bit to make sure that it was working. Then the procedure asked me if I wanted to run a software update right away, to which I responded with a yes, and so it started checking for any updates, and then it started downloading them automatically, and finally it installed all of them. This part took a while, but probably because there were numerous updates to take care of. I would just like to mention that all the RPi 4 that are sold nowadays have the ability to boot from a USB disk without any special modification. However, I read that the boot program stored on EEPROM in the first RPi 4 deliveries didn't have the capability to do that. But if that is your case, you just need to head to the official Raspberry Pi site, where they have a procedure to flush the EEPROM with a new boot program that has the capability of working from the USB in addition of working from the microSD card. Once the EEPROM is flashed with a new code, it becomes possible to run the exact procedure I followed. Actually, you could flash the EEPROM also on all the previous versions of the RPi, like the 3 or the 2, and those two will be able to boot from a USB disk. However, those RPi versions did not have a USB V.3 connector, so the use of a disk in those old versions would not have the same speed benefits than the RPi 4. But you can still do that if you like, to have something more reliable than a microSD card to run from, and or a storage unit with a much bigger capacity. Anyway, once the update was done, I just had to hit the OK button and then click on Restart to have the system completely updated and ready to be used. After that, I made a few more adjustments to set the appearance the way I liked it. I also changed the RPi configuration to activate VNC and the SSH protocol, which I both use often to connect to the RPi from my workstation. And I completed all my changes also by installing some tools that I often use in the lab, like the Firefox web browser and the Arduino IDE. Let's now put everything together. The RPi goes here in this position and will be held in place with a few of these sticky pads, one for each corner of the bottom side. Initially I peeled off just one side and attached the pads to the bottom of the RPi case. I could have removed this plexiglass box and put the naked board in this new case, but the original case keeps the hardware safe and electrically isolated, and it also helps in holding the fan that is needed to cool down the CPU. Then I peeled off the other side of the pads to stick them to the inside of the new case in such a way that the connectors remain available through the side holes of the new box. The SSD went here on the side in such a way that its connector shows through the corresponding hole in the box. I held that in place with another couple of sticky pads. And once everything was done, I closed the box with its cover. At this point I connected the disk to the RPi with this external cable, which is longer than I wanted, but it does the job anyway as long as it is folded like this and hold it in place with this zip tie. When you do that, please make sure the disk is connected to a USB V.3 port, which are those with a blue band inside. This dongle is for the keyboard and I plugged into a USB V.2 connector. And we still have a few more connectors that could be used to connect a network cable, for example, and for a couple of more USB devices. On the other side we connect the power supply, the monitor, a second monitor if needed, and an audio jack that I will probably use to connect the RPi in the future to a pair of PC speakers. And last, I also attached 4 little anti-skid pads to the bottom so the box will not slide on the surface where it will stand. For the final test, I put everything together on the workbench shelf, where the RPi will normally sit. I attached to it this big monitor, which I can now use with no problems since the improvement in the speed of this little computer. The box is located just behind the monitor, and I connected it to the monitor and to the power supply with the switch button. Let's now power it up and see if it works as expected. And yes, the RPi works just fine, it booted much faster than it used to do with the microSD card. Let's now play a little bit with it to see that it actually responds faster to my commands. So here I opened a couple of Firefox windows that came up at a reasonable speed. And now let me get rid of one of the 2 windows and let's use the other one to go to YouTube. It is now loading all the contents of the main page, and it still responds well all considered. Let's go now to my channel. The list of my videos. Yeah, it looks like it is showing the thumbnails at a good pace. Let's close this window now and turn off the computer. To do that, we need first to do a shutdown and wait for the green light inside the box to stop blinking. Only at this point we can turn off the power via the switch button. Here, done. Okay, this was a one-of-a-kind video. Rather than talking about electronics, we put together a Raspberry Pi 4B with an SSD, rather than the usual microSD card. It was a smooth and easy process, also helped by the latest technology made available by the Raspberry team. I'm sure I will be able to use this little computer much more efficiently than before for any lab application for which I need one. Here in the lab, I am relatively distant from my workstation, and having around a laptop it is not exactly the best, given the restricted space through which I usually move around when working with electronics and shooting YouTube videos. Using a little Raspberry Pi connected to a monitor on the top shelf of the workbench seems the perfect solution. I would not be able to use a laptop from there, and besides it would cost me definitely more than a Raspberry Pi. Please don't forget to give me a thumb up and to subscribe to the channel if you find my videos interesting. I'll see you soon in my next video, and in the meantime, happy experiments!